So let's continue our journey through the control section. Not far to go now, so stick with it. So let's look at the data instruction. What the data instruction does is it goes to the next address in the RAM and it pulls out that information and puts it into a register given by RB. So really what we're saying is that the next address in RAM won't hold an instruction, it will hold data, and we take that data and we put it into this register here. So the data instruction is given by 0010. These two bits are not used, and this is the register B. In this instance here we're pointing to register 2. So we could see here that we're loading the 8 bits from the next RAM address into R2. Okay, so in red here we're really saying load from next RAM address to a register. So that's what the data instruction does. So best seen by actually building it up in Logisim and working through a simulation. So let's go and do that now. So if you head down to the resources section, there's a file called data instruction, so you can go and open that up, and when you double click on CPU, this will open up the CPU file. So I'll zoom in on that so we can get a bit more detail. Okay, so we have the usual CPU you've seen in the previous few videos. You'll notice here that I've disconnected the instruction register because we're going to put in our own data instruction. So the data instruction we're putting in is the 001, and we're also going to write to register RB. So the RB we're going to write to will be register 3, so that's this one here. I'm also going to put a value into the memory location here, so let's just put a value 01. 0101. Okay, so that's going to sit in effect in the first memory location here. So what the data instruction does is it goes to the next memory location after the actual instruction, and it takes that value within that next memory location, which in effect now is not going to be an instruction, it's actually going to be our data. And it takes that data out and it's going to place it into, in this case it's going to be register 3, so that's the 1 here, will give us 0, 1, 2 and 3. Now we can't quite see this working properly because we don't have all of the controls set up within the control section. So for example, we don't have the fetch execute cycle, which would normally be over 1, 2 and 3, so the fetch would have been done over steppers 1, 2 and 3, but I wanted to leave that out because I only wanted to put in one little function at a time, just to so that the diagram doesn't get cluttered and you don't get lost. Okay, so what we're really assuming here is that this data, this instruction here has already been fetched out of the RAM, and it's gone into the instruction register, and the bus has been set high and there's a value of 1 sitting here, so it's automatically pointing to the next memory location. But what we're going to do is we're actually just going to stick this value in to the first memory location, so we're kind of assuming that there's a, if you like, a memory location -1. Okay, that this thing is already, the instruction's already been taken out of, and now we've already hopped on to the next memory location. So we're going to put in the value 01010101 into this memory location, and in effect this becomes the next byte, which is our data byte, and we're going to drag the data byte out and into the register. So this is our simulation set up, ready to go. We've got our instruction here, which the first 4 bits tells us that it's going to be our data instruction, and it tells us that we're going to put the information into the register 3, which is this register here. So let's go ahead. So nothing's going to happen for the first 12 clock pulses. and we get to the 12 clock pulse, we should be in the first point of our control section. So let's have a wee look down into the control section. We'll see how it's wired. So now you can see this is our instruction coming in here, and you can see that this third bit is going high here. So it means that when the third bit's going high here, it's picking out the first second, the third AND gate down. So now the third AND gate down has gone live. So now we've got these three AND gates are live in one leg, and the other leg goes to the stepper. So now what we're doing is we're going to step through these instructions here. Okay, so there's three sets of things that we're going to do. So we're going to talk through those just now, but just to note that the rest of the videos on the instruction set, there's not a whole lot of extra circuitry to be added, because all we're going to be doing is we're going to be working our way down these AND gates, and each of the AND gates will allow us to include another instruction. So let's go ahead and we'll work out what's going on here with these instructions here. So we're in position 4 here. This AND gate has gone live. It's chosen this line here. Now the first thing to note is that we've actually got a connection out here into our bus 1. So whenever the original instruction here would have been fetched, we would have incremented the bus by 1, which is telling us it was setting the fetch cycle up so that it then points to the next instruction, which it will go and it fetch out after it's fetched this one. But now what's happened is we get to step 4, we've actually added another one onto it. Now the reason for doing that is that whenever we work through this instruction here and we get to the end, we don't want to point to the next address, because we know that the next address doesn't contain an instruction. The next address contains the data, which we're going to go and stick in the register just now. So we want to make sure that whenever we've been through this instruction here, the next instruction that we actually pull out is not the very next one. We actually got to skip over the next one because that's going to be the data. Okay, so that's why we've got this extra line in here. So we can see here also that the instruction address register is enabled. So if we head up to the top level, you can see here we've got the instruction address register here has been enabled. So the value that's in the instruction address register goes on to the bus. Now if the original fetch cycle had been employed here, that value would actually have been at a value of 1, because we would have added 1 on from the very start of the cycle. But because we don't have that fetch cycle, it's actually just going into the 0th one. Okay, so it's going into the very first address here to pick out a value, and we've nobbled it, so it's actually going to pick out this value here. Okay, so let's go ahead and we'll have a look what else it's going to do here. So now it's got the memory address register is going to be set and the accumulator is going to be set. So you come down here and you've got the memory address register that's going to be set here. So we're taking the value 0 from the bus and getting it to the memory address register, so it's pointing at the first memory location, and of course it's going to load this one in here because we've nobbled it. And we're also going to look, and it's going to be the accumulator here is going to be set as well. So we head in here, you can see that whenever we get to the next clock pulse, actually I'll do the next clock pulse. So that's the set, so that's the accumulator set as well. So it's taken this extra 1 that we've put in and it's popped it into the accumulator. Okay, so it means that it will now be pointing, whenever this value goes along, goes into the instruction register, instruction address register, it'll be pointing at not the next instruction, because we know that's data, it'll be pointing at the instruction after it. So let's head on to the next part of our control section. So that's the clock enable gone high here, and let's have a look and see. We should be on step number 5 here. So I'll just zoom out so we can see it properly. Okay, so we're in step number 5 here, and this second line here is gone live. So what we're going to do is we're going to take the contents of the RAM and we're going to enable it onto the register that's pointed to by this reg B, which is going to be register 3. Okay, so let's have a look and we'll see that on the top level. So you see here that the RAM has now been enabled, so we've taken the contents of the first memory location, which is our 0101, we've popped it onto the bus, and then the next clock pulse is the set, and you can see here that in the set the RAM is going to be and the next clock pulse the register here has been set. Okay, so that's our taking our value 11, okay, and so it's pointing to this 0, 1, 2, 3, the third register. So that's been set. So we've taken this, the contents of this address here, and we've put it into the register. So we know the contents of this address now, those are 8 bits, those are actually data bits, and the data bits are sitting in this register. So let's continue to the next section, we'll see what there is next. So here we have our in step 5, so let's click along to step 6 and we'll finish this off. So let me make this a bit bigger for you. So step 6, there's a clock here until the clock goes enable and we'll be in the next position. So that's us in the next position here. So head back down and we can see we're in position number 6 here, and now we're on this line here. Now we've got the accumulator has been enabled and the instruction address register is set. So the accumulator here will be enabled. So what we're doing is we're taking the value here, which is the now pointing to the next memory location. So remember, it's not the data location it's pointing to, it's the one after that. Okay, so it just jumps over one of the memory locations here to get to the actual next data instruction, the next instruction. So we've done that there, and then whenever we click on the set goes high, and we're actually reading this into the instruction address register. So that's the instruction address register now got pointing to the correct location. So that's us finished with the data instruction. You can see here that the instruction address register is actually, there's only a value of 1 there, but if we had the fetch cycle already built into the control section, that would be sitting at a value of 2, because we would have added an extra 1 through this bus here. So really what you would have seen is that the next instruction would now be coming from position 2 within the memory. Okay, so the position 0 would have been the original data instruction, the position 1 would have been the data, and then the position 2 would be the next instruction. So that's all there is for the data instruction. I'll get you on the next video. Thank you for watching, and goodbye.